Welcome to your video on matrix algebra, which is the second lesson on working with matrices. So this lesson is going to give you a little bit more information on adding, subtracting, multiplying, and well, maybe not yet quite dividing matrices. So the first thing that we have is something called equality of matrices. So notice that it says we can have two matrices that are equal if they have the same order and all the corresponding elements are equal as well. So the very first thing that we're trying to solve for, it says we're trying to figure out what the variables are actually equal to if we're looking through this matrix. Notice how the matrix on the left is a 2 by 2. Matrix on the right is also a 2 by 2 in this case as well. The nice part about this is there's some things that have to be equal. The one spots have to be the exact same as one another if they're equal. The 1, 2 spots have to be the same. And we can keep going, obviously, all the way through with the 2, 1 spots, and last but not least, the 2, 2 spots as well. All right, so basically what we can then put together is we notice the greens, -4 equals -4, we're all set with that. All right, if we want to write that out, we most certainly can, but it really doesn't help us except for the fact that says these two matrices are equal. We could go to the black. The black tells us that 7 has to be equal to 7. So all good with that part as well. Everything matches up. Notice how the red starts to help you out because when we put those two together, it tells us then that our y is the exact same thing as 5. So then when we go to the blue, actually, and say that x has to be equal to 2 plus y, well, we know that y is actually equal to 5, which then allows us to find out what x is equal to, which in this case is an actual 7. So the equality of matrices helped us solve for a few variables. And if we're trying to look at this next piece of information, kind of similar in this front, where we also have a 2 by 2, so kind of the same, so we can kind of use the same colors here to make sure things match up if we want. And it's almost like a little puzzle that you're trying to put together to see what actually is equal with everything that we have. And you'll notice that as you're going through a couple of the pieces of information, some of them might work out nice, some of them might not work out so nice, but your goal here is to try to figure out what values work. So I always say start with the easier equations first. The easier equations to me are the ones that don't have any squares in them. So I'm going to start with the green equation that I have. A 2b plus 1 is equal to 9. I'm going to solve this for my b. When I do, notice how my b is equal to 4. All right, so we know in this case that b has to be equal to 4. Here's the key, though. Whenever we find one of the values, it has to work for all other b's that we have. There is another equation that has b's, and it's a 16 that's equal to b squared. Now, before, if you remember, when we take the square root, we created the square root, so we have two answers in this case. So over here, we get a positive and a -4. So in order to figure out what the actual real answer is, both numbers have to work in all equations with b. Well, we know +4 works in both. The problem is the -4 does not work in both equations. So it's kind of misleading here because even though we know positive and negative is true, the negative doesn't work in the green equation, which means our b is actually just equal to a regular old 4. The reason that's important is because if you take a look at the next piece of information, we have our red equation that is 2a plus 1 that's equal to a -5 in that case. We get a 2a that's equal to a -6, or now we get an a that's equal to a -3. So we have one answer, or part of our answer, but we still need to do the blue equation, which again, you can kind of see what's going to happen here. We create the square root, so we need a positive and a negative answer for our a, but again, only one of these values works. So unfortunately, in this case, the positive does not work, so all we have is a -3. So we found our two answers that we would write for our actual final answer would be b equals 4, and a would be equal to a -3 in terms of this starting equality of matrices. Now the nice part is we can use this information to actually work with our operations. So it says two matrices can be added or subtracted only if they have the same order. So adding and subtracting has to happen if they actually have the exact same order with one another. So you'll notice here that there are three different matrices actually provided: a matrix A, a matrix B, and a matrix C. And the first thing I recommend doing is putting the order down for each one of these. Because we know that A has two columns, two rows, three columns. This is a 2 by 3 matrix. Matrix B has two rows with three columns, 2 by 3 for that matrix as well. Notice how C looks a little different because now there's 3 rows in this case and 2 columns. So we need to look at what notation is actually being provided to us here. And the first thing it says, A plus B. That means we need to take A and add it with B. So do these match up? The orders are the exact same, so that is good. That also means that our end result has to be a 2 by 3 matrix as well. So it's not 1, 1. We're going to add together the 0 and the 4. So we add those to get 4. We continue with this. We add the 3 and the 1 to get a 4 as well. We add the -5 and the 0 to get a -5, and we keep adding the numbers that are in the same spot. So we end up then with a -1, a 5, and a 4 for our final answer. That's all you have to do when you're adding together matrices. So now the next one, notice it says A plus C. So now with A plus C, we would have to look at the order. We have a 2 by 3 and a 3 by 2. They have to be the same order for us to be able to multiply these together. Unfortunately, they are not. This is not possible. Or you could write no solution. Either one of those answers would be perfectly acceptable. All right. Now, we are going to do a subtraction example in just a second. But notice how both these are addition. Addition is really as easy as you could possibly get. Okay. The next piece of information talks about matrix multiplication. It talks about a scalar. And a scalar is just when you multiply something with one number. Right? It says multiply a scalar by any number, and every element has to get multiplied by that scalar. So hypothetically, again, I'm going to use the exact same 3 matrices that we had. So again, I have to put in here 2 by 3, putting the order down for each one of these so that we can actually determine what the question is asking. The first piece of notation now says 3A. That means that we're multiplying everything in this matrix by 3. So everything in there is being multiplied by 3. Order does not matter when you just have scalar multiplication. So in this case, well, we have a 0, we have a 9, we have a -15, we have a 3, we have a 6, we have an 18 for our scalar multiplication. If we're looking at the second part where it says a -2b, and now everything is being multiplied by a -2, which is going to kind of help us lead into some of our subtraction examples that we'll get to in a second. Because now we multiplied everything here by -2, we get a -8, we get a -2, and a 0. We multiply the -2 with the -2 that's in that first spot for a 4, -6, and a 4. Right. And the only way, I guess we can make it a little more difficult, is to include scalar multiplication with addition. So notice, excuse me, notice that before we can add together, we actually need to multiply the first one by 2, the second matrix by 4. So let's do that. We have the first matrix, that is A, multiplied by 2. 0, 6, -10, 2. We get our 4, our A, and last, the 12. That is our 2A matrix. Now, let's add it together with our 4B. So let's multiply everything here by 4. 16, 4, 0, -8, 12, -8. So that's just the multiplication with those two. Now we have to actually see if we can add these together. And you will notice, excuse me, you will notice that when we do add these together, the orders are the same. So we can actually add them together. We get a 16, we get a 10, we get a -10 in that spot. We get a -6, we get a 16, and we get a 4. We have used scalar multiplication to take 2A plus 4B to have it equal to a 2A plus 4B at the very end. So we've used scalar multiplication, we've used addition. Now let's kind of break that into the next spot here. Because you'll notice that with matrix multiplication, like actual multiplication, okay, the first thing we have to make sure is you're not just multiplying the entries, all right? There's something called a row by column method, all right? So it says in order to be able to multiply matrices, the number of columns of the first matrix must be equal to the number of rows in the second matrix. So a little diagram here. Okay. If you hypothetically have a 3 by, and then we'll say 2 matrix, and in the other respect, you have a 2 by, we'll say 3 matrix. The key here is that the middle numbers need to be the exact same. That's what the picture is demonstrating. All right. If those middle numbers are the exact same, you will be able to multiply. Excuse me. If you have those the same, the outside numbers are going to be the resulting matrix. So then in this case, our red and green here is going to be the order of our new matrix. And as long as those middle numbers are the same, we're going to be able to continue and actually solve for some problems. So the first thing we have to do is test the order. So if we're testing the order, we have a 2 by 3 in this case. And the next one you're looking at is also a 2 by 3. In order to multiply these two things together, the middle numbers need to be the same. And this first example, that is not the case, actually. So unfortunately, the middle number is not the same. This can't be multiplied. It's a no solution. There's nothing you can do if those middle numbers do not match. Okay. Now let's take a look at the next one. Here we have a 2 by 3 in this case. We have a 3 by 2. So the beautiful part about this now, those match. Okay. That means our resulting matrix is going to be a 2 by 2. So I'm going to put that right off to the side, but we're going to have some work to do before we figure out what numbers actually go in that spot. Okay, so here's the key. When you're multiplying matrices, this row by column is very important. So I'm going to erase a few of the things that I have here because I'm going to have to jot some stuff down here. What we need to do is take the first row and multiply it by the first column. Notice how we have row 1 and column 1. That gets back to our 1, 1 spot. Okay? When we actually put all these numbers together, that final answer is going to go in the spot 1, 1. So what we need to do is we need to take the 0 and multiply it by a 4. So in this actual spot 1, 1 here, we're taking the 0 and we're multiplying it by 4. It's the first spot in each the row and the column. Okay? We then need to multiply the 3 with the 6. So we need to multiply the 3 and the 6 together. And then last but not least, we need to multiply the negative 5, excuse me, in this case by the negative 2. Negative 5 times negative 2. So notice how we have essentially like 3 different answers that we find for each one of these spots. And then what we have to do is add each one of those together. So we know 0 times 4 is 0. 3 times 6 is 18. Negative 2 times negative 5 is 10. So when we add all those numbers together, the answer that we should get in that very first spot of our column 1, 1, or spot 1, 1, or spot 11 should be a 28. Now we need to do that exact same thing with every single spot. And it may seem like a lot, but once you get the hang of it, it is going to go a little bit better. So now that was our spot 1, 1, which means you used row 1 and column 1. We're using row 1, which is nice and perfect, and we still use that same thing. But now we have to use column 2, row 1, column 2. So if that's the case, now we're taking that second column and actually multiplying some things together. So when we do that, let's actually write that out. We get our 0, the first number, times 1. 0 times 1. We're going to add it with the middle numbers. 3 times 2. 3 times 2. We're going to add it with a negative 5 and a 3. Negative 5 and 3 in that case. And as we go through now, we can actually fill this in with a 0 for the first multiplication, a 6 for the second one, negative 15 for the next one. We actually wind up with a negative 9 in that case. Right? Now, what I want you to try is I want you to try to go through and see if you can fill in these other two. Because in this case, we are going to have our row 2, column 1. So row 2, column 1 is what you're looking at there. So that green would have row 2, column 1 being multiplied together. The final answer that you should get for that one is going to be a 4. And for the very last spot that you have here, this is your row 2, column 2, your spot 22. So in that case, we would have our row 2 with our column 2. Multiply those two together to see if you can get the final answer of 23 in that spot. Pause the video, see if you can get those to match. Now that you've tried the A times C, notice that the very next one says C times A. So all we did was split the order. And with normal multiplication, it wouldn't matter. 3 times 4 is the exact same thing as 4 times 3. But does it matter with multiplying matrices? Okay, it doesn't have the same properties as regular multiplication. So the first thing we have to do is figure out what the order actually is. And if we do that, we have our 3 times 2 in that case, and our 2 times 3. So notice middle numbers match, outside numbers would be the end answer. So in that case, we would have a final answer. It'd be a 3 by 3. So already that tells you right there that multiplication cannot be switched. We know that AC is not the same as CA. That's a very big rule and property that hopefully you're going to realize already, because our end matrix is already going to be different than what we did in the last one. All right. So now this is the key for you. Again, I want you to try this on your own. When you're looking at your 1-1 spot, and as you're going through that 1-1 spot, the first row, again, row with your first column. That would be your spot 1-1, the very first number that you're going to have. If you do that, you should find out that that answer ends up being a 1. Okay? If I'm going to the next spot now, row 1 and column 2. Remember, rows always come before columns. When you put those two pieces of information together, you should get a 14 as you go through. And last, well, certainly not least, row 1 and column 3. That is your spot 13 on your matrix, and that is a negative 14 as you go through. So I'll let you pause the video now. I'll write in the rest of the answers, and you can check your work as you go through. Now that you have tried each one of the matrix multiplications, you can check your answers over and see how you did. If you got one spot wrong, like whatever the spot 32 or 23 or 22 is, today see if you can go back to just that multiplication and find out what your actual answer was. And if you can, awesome. If you can't, then that would be where you would contact Mr. V and see if he can help you find your mistake. All right. But now your practice is going to be one of your favorites. It's one of Mr. V's joke worksheets. You can look at the Google Doc to figure out where that is and check your answers over. Have a good rest of your day.